Hello Prep 3. Today we are going to talk about Unit 2, Electric Energy and Radioactivity. Lesson 1, Physical Properties of Electric Current. Physical properties of the electric current. Okay. Firstly, we must know what's meant by electric current. The electric current, as you know before in the previous years, the electric current is a flow of free electrons. Flow of free electrons. How can we obtain a free electrons? You know that the structure of the atom consists of nucleus, and the nucleus contains positive particles which are called protons and neutral particles which are called neutrons. And there is particles that are negatively charged rotate around the nucleus. Okay? These particles that are negatively charged called electrons. There is attraction force between the positive protons and negative electrons. There is attraction force between positive protons and negative electrons. When this attraction force becomes weak attraction, so the electrons become free and can flow through a conducting material. When a free electrons flow through a conductor material, this is called electric current. So now, what's meant by the electric current? Electric current is a flow of free electrons in a conducting material. Flow of free electrons in conducting material. Okay? And now let's see the physical properties of electric current. Physical properties of the electric current. These are the physical properties of electric currents. In this lesson we have 3 properties. Number 1, electric current intensity. Number 2, potential difference. Number 3, electric resistance. In this video I will talk about the first 2 properties only, current intensity and potential difference. The electric current intensity equal a quantity of a charge symbolized by Q divided by time in second. So pay attention please, Prep 3. I can define the electric current intensity from this rule. Electric current intensity, if you look at the rule, electric current intensity equal quantity of a charge divided by time in second. So I can define the electric current intensity by, it is a quantity of a charge that passes through a cross section of a conductor in 1 second. Again, what's meant by electric current intensity? Yes, it is a quantity of electric charge, which are free electrons, that passes through what? Passes through a cross section of a conductor in 1 second. This is called electric current intensity. Pay attention, Prep 3. This lesson contains many definitions and many concepts, so please pay attention. When I say quantity of a charge, I must say pass through a cross section of a conductor. Quantity of a charge, pass through a cross section of a conductor. Again, for a third time, what's meant by electric current intensity? It is a quantity of charge, of electric charge that passes through a cross section of a conductor in 1 second. Okay? Okay. Now, what is the measuring unit of electric current intensity? Is ampere. Measuring unit of electric current intensity is ampere. And the measuring unit of the quantity of a charge is coulomb. Coulomb. Okay? And the time its measuring unit for sure is second. Okay? Now, these are the measuring units of each one. Again, electric current intensity, its measuring unit is ampere. And quantity of charge, its measuring unit is coulomb. And the time, its measuring unit is second. Okay? And this is here the magic triangle. I can put the quantity of a charge at the top. And here is the electric current intensity, and this is the time. If I want to calculate the quantity of electric charge, please put your hand on the quantity. So the quantity of electric charge equal electric current intensity multiply time. If you want to calculate the electric current intensity, so put your hand on I, electric current intensity. So electric current intensity equal, yes, quantity of electric charge divided by time. If you want to calculate the time, so the time equal the quantity of electric charge divided by electric current intensity. Okay? Pay attention here from the magic triangle. There is many relation. The relation between the electric current intensity and the quantity of electric charge. Electric current intensity and the quantity of the electric charge. This is a directly proportional. Directly proportional. So, if I use the graph like this, if I use the graph to find the relation between the electric current intensity and the quantity of the electric charge, electric current intensity and the quantity of electric charge, this is directly proportional. This is directly proportional, represented by a straight line passing by the original point. Okay? And there is another relation between the electric current intensity and the time. Electric current intensity and the time. Here the electric current intensity is inversely proportional to the time. Inversely proportional to the time. When the time increase, the electric current intensity decrease and vice versa. When the time of passing a quantity of electric charge increase, so the electric current intensity decrease and vice versa. Here is an inversely proportional between electric current intensity and the time. Electric current intensity and the time. So if I ask you what happens by increase, okay, here I have the electric current intensity equal, I will say it again, the electric current intensity equal a charge, a quantity of the electric charge divided by time in second. So I can define the electric current intensity from the rule by it is a quantity of electric charge, and we say that we must say quantity of electric charge that passes through a cross section of a conductor. Once I say quantity of electric charge, I must say passes through a cross section of a conductor. Okay, so what's meant by electric current intensity? It is a quantity of electric charge that passes through a cross section of a conductor in 1 second. This is the definition of electric current intensity. And we said that the electric current intensity, its measuring unit is ampere. This is the measuring unit of electric current intensity. And the measuring unit of quantity of electric charge is coulomb. And the measuring unit of time is second. Now, if I ask you about what's meant by ampere, what's meant by ampere? Pay attention. This lesson contains many definitions. You can answer the definition or you can know the definition from the rule by easy way. So please pay attention. If I ask you about what's meant by ampere, the answer will be ampere. It is the measuring unit of electric current intensity. Yes? Yes. So the definition of ampere starts with it is the electric current intensity. This is number 1. It is the electric current intensity. Okay? When, this is number 2, when a quantity of electric charge, and we say that we must say a quantity of electric charge passes through a cross section of a conductor equal 1 coulomb, equal 1 coulomb in 1 second. This is number 3. In 1 second. You got it? Again, if I ask you about the definition of ampere, I will say that the ampere equal, it is, the ampere, it is electric current intensity. Electric current intensity when a quantity of electric charge pass through a cross section of a conductor equal 1 coulomb in 1 second. It's so easy now, right? Okay, now let's see how can I define the coulomb. How can I define the coulomb? What's meant by coulomb? What's meant by coulomb? Coulomb is a measuring unit of the quantity of electric charge. So I will start my definition by, this is number 1. I will start my definition by, it is a quantity of electric charge. It is a quantity of electric charge that passes through a cross section of a conductor. Passes through cross section of a conductor when the electric current intensity equal 1 ampere. This is number 2. When electric current intensity equal 1 ampere in 1 second. This is number 3. In 1 second. Okay? Again, what's meant by coulomb? I know that the coulomb is a measuring unit of quantity of electric charge. Coulomb is, number 1, coulomb is the quantity of electric charge passes through a cross section of a conductor when the electric current intensity equal 1 ampere in 1 second. Okay, you got that? Okay, these are the definitions that related to the electric current intensity. These are the definitions that related to the electric current intensity. There is a problem here. I can ask you about the value of electric current intensity if you know that the quantity of electric charge and the time, so you can calculate it easy. Okay? Okay, And here I have the emitter. This is the device that I can use it to measure the electric current intensity. So we can use a meter to measure the electric current intensity. How can I use the emitter to measure the electric current intensity? I will connect the emitter in the electric circuit. Pay attention, the emitter has two poles, red one and the black one. The red one is positive pole and the black one is negative pole. When I connect the emitter in the electric circuit, I must connect the positive one to the positive pole of the battery and the negative one to the negative pole of the battery. And I must connect the emitter in the electric circuit, in series connection. In the electric circuit, in series connection. Okay. So here I have the emitter. It is a device used to measure the electric current intensity. I connect the red pole, which represents, red pole represents positive pole, to the positive pole of the battery, and the negative pole, which is black, to the negative pole of the battery. And here I can measure the electric current intensity. I must connect the emitter in electric circuit in series connection. Pay attention, we can't connect the emitter directly to the battery as this will damage the emitter. Okay. Now number 2, the second property of the electric current is called the electric potential difference. The electric potential difference. The potential difference between the two poles of a conductor. Pay attention, if I have two conductors and connect them with electric wire, the electricity will travel from the conductor that has a high potential difference to the conductor that has low potential difference. So the direction of the electric charge from a device that has high potential difference to the device that has low potential difference until both of them have the same potential difference. Okay? So the transferring of electric charge from one conductor to another, if they are connected together, depend on the potential difference, not on the quantity of electric charge. The electric charge will travel from a conductor that has a high potential difference to the conductor that has low potential difference. Okay? Here, how can I calculate the potential difference? How can I calculate the potential difference? From this relation, the potential difference equal work done divided by the amount of electricity, which is Q. From this rule, as we make in electric current intensity, I can define the concepts by the help of their rules. The potential difference equal work divided by quantity of electric charge or the amount of electricity. So what's meant by potential difference? I can define it by the potential difference equal, or it is the work that is done to transfer the quantity of electric charge between the two terminals of the conductor. Pay attention, if I say potential difference, I must talk about the difference between the two terminals of conductor. Again, what's meant by potential difference? Potential difference is the work that is done to transfer a quantity of electric charge between the two terminals of the conductor, between the two terminals of the conductor. Here I will talk about the measuring unit for each one. Potential difference, its measuring unit is volt. Work, its measuring unit is joule. Amount of electricity, its measuring unit is coulomb. So how can I define the volt? As we made in electric current intensity, how can I define the volt? Start with volt is, yes, it is a measuring unit of potential difference. So I will start my definition by volt. It is the potential difference between the two terminals of a conductor when the work done equal 1 joule through transfer an amount of electricity equal 1 coulomb. Again, what's meant by volt? It is a potential difference between the two terminals of a conductor when the work done is 1 joule to transfer an amount of electricity equal 1 coulomb. This is the definition of volt. Okay. Now let's see how can I measure the volt by using a device called voltmeter. It's symbolized by V. Pay attention. Voltmeter as the ammeter. It has red pole, which is positive pole, and it has black pole, which is negative pole, and I must connect the positive pole of voltmeter to the positive pole of the battery, and also the negative pole of the voltmeter to the negative pole of the battery. Okay? Ammeter is used to measure the electric current intensity, but voltmeter is used to measure the potential difference. Ammeter is connected in series connection, but voltmeter is connected in parallel connection. Pay attention. Look at the two figures in front of you. Here I have two cases. The first one, I connect the voltmeter with the two terminals of a conductor in parallel connection. Here I will measure the potential difference of the conductor. In figure 2, pay attention. Here I connected the voltmeter between the two terminals of battery. And pay attention. In the figure 2, the electric circuit is opened. This means that there is no electric current here. So here the voltmeter used to measure the electromotive force of the battery. Again, I have two cases here. In figure 1, the voltmeter is connected between the two terminals of a conductor, and here the voltmeter is used to measure the potential difference between the two terminals of a conductor, and the electric circuit is closed. In figure 2, I have the voltmeter is connected between the two terminals of the battery, and the electric circuit is opened. So here the voltmeter is used to measure the electromotive force of the battery. So what's meant by electromotive force? Electromotive force, it is the potential difference between the two terminals of the battery, or two poles, or two ends. Okay? It is the potential difference between the two terminals of the battery when the electric circuit is opened, or when there is no electric current. Again, what's meant by electromotive force? It is the potential difference between the two terminals of the battery when the electric circuit is opened and there is no electric current here. So from this I can conclude that I can use a voltmeter by two ways to measuring two things. Number one, I can connect it by parallel way between the two ends or two terminals of a conductor to measure the potential difference of a conductor. Number two, I can connect it between the two terminals of the battery in opened electric circuit to measure the electromotive force of the battery. Thank you, and we will complete our lesson in next video inshallah. Thank you, prep 3.